In section 2.3, we're going to talk about measures of central tendency. These are the different ways we can describe the center of a data set. And typically, we talk about mean, median, and mode. I do assume that you are familiar with these basic ideas, so I'm going to focus instead on the notation for them, which may be new. You've got plenty of examples in your book to go look at if you do need a refresher course on your basic. The symbol that we use for the sum of a set of data values is, as we've seen, the Greek letter capital sigma. The variable we usually use x for our variable. And the number of data values in a sample versus a population. For a sample, we let the number of data values be little n, lowercase n. And for population, we use capital N. The mean of a set of sample values, we use the symbol X with a bar over the top of it. And the mean for a set of population values, we use this Greek letter mu. Very often, we reserve English letters from our alphabet to represent sample statistics, and then we pull out the Greek letters for any kind of population parameter. So down below here, you should be familiar with the mean, which is found by adding up the data values and dividing by the total number of them. So in symbols, you should be used to seeing some formulas for this. So the population mean, this mu, you calculate that by summing up the pieces of data and dividing by the total number of pieces of data in the population. Now, if we write the same formula, but for a sample, we would switch from mu to x bar. The sample mean is the sum of the variables divided by little n, because little n is the size of a sample. Okay, please get used to reading statistical formulas. The median is the middle when you put the data in order, and that's the important thing to remember about that. For the mode, which is the most frequent piece of data, there are two definitions that you should know. A data set that has two values that occur most often is called bimodal, and a data set in which no value appears more than once, we say it has no mode. We don't report it as zero mode because zero is a number that could be the mode. We are going to practice these with an example. So this is example 6, which I believe is a data set from your book. It says, below is a sample of ages of students in a class. Find the mean, median, and mode of the ages. Which measure of central tendency best describes a typical entry of this data set? To calculate the mean for this data set, this is a sample, so I am using the formula x bar. So if you take this list of numbers that's sitting here and you add them all up, you should get a total of 475. And if you were doing this as a written homework assignment, I would want to see your formula and then your in-between steps before getting to your answer. Then you would divide by the number of pieces of data, which is 20. You pick up your calculating device and you get an approximate value for that, which I'm going to round to one decimal place. So I'm going to say it's about 23.8 years. Don't forget units. So that's the average age for a student in this class. Next, we calculate the median. Now, in order to do the median, we have to put the data in order. So we have to basically scan through the entire data set, look for the lowest number, which is 20. Make sure you write it as many times as it appears. And again, crossing them off is kind of a helpful way to make sure that you don't miss any of them. And I'm going to go ahead and finish lining up the rest of this data. So I have my numbers in order. Now to find the middle, it's easiest just to cross off or check off one piece of data from each end working your way in towards the middle. Once you finish that process, you'll notice you will either have only one number in the middle, in which case that is your median, or like in this situation, you'll have two middle numbers. If you have two middle numbers, the median is found by taking those values and finding their mean. In other words, add them up, divide by 2, and that'll be your median. 43 divided by 2 is going to be 21.5 years. The mode is the most frequent piece of data. It's the one that there is the most of. So if you go through this list, we have 20s 1, 2, 3, 4, 5, 6 times. 4 21s, 3 22s, 4 23s. So 20 is the mode because it appears most often. The last part of this question asks you to determine which measure of central tendency best describes a typical entry in this data set. Now, this has to do with the concept of outliers. If you notice, this class is mostly composed of 20-year-olds, but in fact, there is one back to school student who is 65 years old. When you have a piece of data that is far from the rest of the values, that piece of data is called an outlier. There is a formal definition for how far away a piece of data has to be considered an outlier. We will get there eventually. And to give you an idea of the effect of it, if I were to take this 65 out of the data set and recalculate the mean, which I'll do over here, my sum would reduce by 65, so it would become 415 over 19 pieces of data. And by using a calculator, my mean now becomes 21.8 years. Let's see how the median is affected. Well, if I go back to my list and I remove the 65, now when I cross off data from each end, I have a single piece of data in the middle, and that piece of data is the new median. And what I'd like you to observe is that the outlier, when it's taken out of the data set, has a bigger impact on the mean than it does on the median. And that will usually be the case. When you have an average, you can have one piece of data that can really throw off your average. And you should be familiar with this as students, right? If you get a 0 on a test, that crushes your average. If your teacher instead actually graded you and took the median of your test grades, that 0 would not be as significant, which is one argument for why we should use the median. When you have an outlier, you want to stay with the measure of central tendency that is less affected. So we would usually choose the median to be the most representative of the data set. Because what the median is telling us is that half the people are below 21.5 years old, half are above that. And again, it is not as swayed by the presence of an outlier. If you look at the graphic in your textbook, for example 6, it shows a frequency histogram, and you can see that the median is kind of more in the middle of the data set than is the mean. Now we're going to move on to a more complicated version of the mean, which is the weighted mean. So the weighted mean is used when certain values have more effect than other values. The formula for this, the weighted mean, x bar, is found by taking the sum of the pieces of data times their weight. W is going to stand for the weight. And dividing that by the sum of the weights. And again, I'll put a little note here. W is the weight of a piece of data. And again, get used to formulas because you're going to ultimately have a formula page. Here's an example, which again is kind of applicable to you as a student. Example 7 from your book says calculating a semester GPA is an example of a situation where you would need to calculate a weighted mean. The reason for that is when you get your grades, they are for a certain number of credit hours. So getting an A in a 3 credit hour course is more significant than just getting an A in a 1 credit hour course. It's going to have more sway over your average. The table at the right is one student's grades from the fall semester. The grading system assigns points as follows. An A is 4 points, a 4.0, B is 3, C is 2, D is 1, and Buff State uses E for a failing grade, which is no points. Determine the student's GPA. I've created a table where I have a column for the points. I'm going to work with the numerical value for each grade. So those are my pieces of data. Those are my X's. The credit hours indicate how much weighting should be given to each point earned. So that's my W. And in the last column, I have a column for multiplying X times W. My first grade here is a C. A C, according to the system, is worth 2 points. So I have 2 points in a 3 credit hour course. I also have 2 points in a 4 credit hour course. Now you'll go across your chart and you'll just multiply these together. So 2 times 3 is 6, 2 times 4 is 8, and so on. The formula from up above for the weighted mean says we take the sum of the data times its weight over the sum of the weights. At the bottom of the weights column, I will record the sum of the weights, which is 16. And then below the product column, X times W, I'll record the sum of those pieces of data, which is 40. So then I just go over to my formula. 40 divided by 16 is going to generate my mean, and that turns out to be equal to 2.5. So the student's GPA for the fall semester would be 2.5, which means they're maybe in the C plus range, a little bit above a C, but not quite a B. So that's an example of how you calculate a weighted mean. The last type of mean we're going to look at is the mean of a frequency distribution. We'll do that in the next video.